just gonna go through today's class. I know on Thursday you took down some of the notes on acids and bases, so just to fly through these really quickly, and if there's anything that you could add to your notes from the PowerPoint, add them in. So first thing is kind of what is acids, like what are acids and what are bases. As opposed to defining what an acid is, it's more about having examples of what acids are. So I have everyday examples of acids here, and generally they would be kind of, if you were to taste them, they'd be quite sour to the taste and bitter almost. Um, that's from an everyday acid point of view. And then from a lab acid, it would be very, very corrosive. So laboratory acids, especially in high concentrations, are very, very dangerous. Like they could kind of tear the skin off your hands, really, and they would corrode the skin away. So they have examples here of everyday acids: lemon juice, rainwater, vinegar, and lab acids, hydrochloric acid and sulfuric acid. Bases then. Bases are essentially the opposite of acids. And again, as opposed to being kind of describing what a base is, it's more about having examples of bases. So I think people, when you hear acid, I don't know, is it from movies? I don't know, but you have this idea that acids, if you were to dunk your hand into an acid, I think everybody would expect that they would, like, take the skin off your hands and it would bubble and your hand would disintegrate, like all very dramatic. But I think when you say bases, you don't have that same imagery, but actually bases are just as corrosive and just as dangerous as acids. So if you were to put your hand into a strong base, you would pretty much have the same reaction as if you put your hand into a strong acid. It's incredibly corrosive. So your examples here, everyday examples of bases are toothpaste, bleach, indigestion tablets, like Rennie or Gaviscon or something like that. Essentially, indigestion tablets, the ads with the little fireman. So the reason you take indigestion tablets is because you have stomach acid that is kind of coming back up your esophagus. So it's acid that you're trying to counteract. So you counteract acid with a base because they're the opposite of each other. So that's why tablets like Rennie and stuff like that are bases, because they're used to counteract acids. And then your lab bases would be sodium hydroxide, calcium carbonate, and lime water are good examples. They're not the only examples. You just need to know a few. I think this was in the notes. Some bases are soluble in water, so some bases will dissolve in water, and if they do, they're known as alkalis. You should be able to link these in with the periodic table. Do you remember the alkali group in the periodic table? So if you take them and dissolve them in water, it normally produces a gas as well, but it would produce a base, and that base is soluble in water. Most of the time they produce hydrogen gas. Do you remember when we did it, we put them into the water and we got like the reactions and the gas kind of fizzed off the top. Yeah, so they that's where they get their name from. And the alkalis are bases that dissolve in water, so make sure you have that, okay? Sodium hydroxide is an example of an alkali. A substance that is an alkali is said to be alkaline. And there's another group of substances that are, and again, this should be in your notes. So if you're not acid or base, you're classed as neutral. Okay, the kind of classic example of neutral is water. So for most acid-base reactions that we're looking at, we use water as our control, because it's neutral. Okay, so I asked you to have a look. I think you had notes on indicators. So an indicator is a chemical that shows by means of a colour change whether a substance is an acid or a base. You have to be able to do experiments with two, so with litmus paper and with a universal indicator. So I suppose my proposal here is I don't have a science teacher who's coming in to cover for me that's going to be able to do these experiments. Okay, it's not fair to ask someone who's not a science teacher to set up a lab experiment. So for now, we're just going to kind of watch videos about them and get an understanding of it, and then whenever I'm back, we'll do like a solid kind of 3 or 4 classes in a row of experiments, and we'll catch up. I have a list here. So I'm keeping a list of experiments that we haven't done. I mean, technically you have the theory on them, but you haven't actually done them. So you will get an opportunity to do them, okay? So just bear with me, and you will get to do them. Okay, so an indicator, kind of by the name, it indicates, okay? It tells you whether something is an acid or a base. So the first one is litmus paper. Now, these colours are a little bit misleading. Litmus paper, the red one is actually kind of a very pale pink, and the blue one is almost like a lilac-y, purpley colour. So when you see it in the video, and when you see it in real life, these colours are a little bit, the colours are not as strong as this. It's not like a proper red or a proper blue. But essentially you need to know the colours. So you can get red litmus paper and blue litmus paper. And essentially it goes red in an acid and blue in a base. So BB, blue base. Lost my pen. So yeah. Okay, so if you remember BB, you remember blue in a base, then you'll remember that the acid is red. Okay, so in the first one here, this one here started as red litmus paper, and it remained red because we put it into an acid. The second one started as blue litmus paper, but because we put the blue litmus paper into an acid, it turned red. Okay, so the bottom bit here, like red in an acid. So if you use red litmus paper to test it, you will notice no change, and if you use blue litmus paper, it will change to red. In a base, excuse me, in a base, it goes blue in a base, blue in a base. So if you use blue litmus paper, you will see no change in the base, but if you use red litmus paper, it will turn blue. Okay, so you can see that both of them are blue when in the base. Okay, and if you put them in neutral, so if you put red litmus paper into neutral, there would be no change. And if you put blue litmus paper into neutral, there would be no change. Okay, so that's how litmus paper works. Now, I have an experiment here, and I'll give you the link to watch this. So what I want you to do with this, essentially, is I want you to take down the heading. I want you to take down the equipment needed. I want you to take down the method. And then using the bits and pieces that the girl in this video uses. Don't watch the whole start of it because she just explains what I've just explained. So start at about 4 minutes, 4 minutes 11 or something. And that's when she's actually doing the experiment. So what I want you to do is whatever she tests first, you write it up here in substances being tested, and then you tick either acid, base, or neutral. Okay, obviously I would like you to try and get there before she does, before she tells you. And for a lot of them, you could probably predict what they are anyway. So she takes you through, I think, about like 7 or 8 substances. So you should have a table with 7 or 8 things in it, and then you just tick whether they're acidic, basic, or neutral. Okay, and like I said, we'll try the experiment ourselves, and maybe some of the products that she uses, we can use something similar. And create a little table of acids and bases. Okay, so that's what I want you to do. I want you to take down the title. I want you to take down the equipment used, the method, and then create a table. Okay, go into this video, watch it from about 4 minutes, and complete the table. Does that make sense? And that kind of brings us up to, I suppose, what I want you to have today. So just make sure that you have notes on acids and bases. So what is an acid? And again, it's not really about what is an acid. So you need to know that an acid is, it has the words. So you need to know that an acid is corrosive. If you were going to taste it, it's sour or sharp, or what was the other word I used? Bitter tasting. Okay, so you should have that there. And then you need your examples. Okay, so a couple of everyday examples and a couple of lab examples. What are bases? Good idea to know that they are the opposite of bases. and that they are also very corrosive. I would have that in. And then again, some everyday examples and some lab examples. You need the notes here on bases that dissolve in water being called alkalis. Um, and you also need to know that when you are neither an acid or a base, you are referred to as neutral. What does an indicator do? So this sentence here, on an indicator is a chemical that shows by means of colour change whether a substance is an acid or a base. We're going to look at two types of indicators, 1, 2, and the first one we're going to look at is litmus paper. So I've described here how litmus paper works. There are two different types of litmus paper, red and blue, and again, they are not very strikingly red or blue when you see them in real life. But essentially, if you put litmus paper, regardless of the colour, into an acid, it will be red. So it will either turn red or it will stay red, depending on which one you used. If you put litmus paper into a base, base goes blue, BB. So again, regardless of which one you put in, it will be blue. So it will either change to blue if you use red paper, or it will stay blue if you use blue paper. And then if you put it into neutral, you will notice no change. So red will stay red, blue will stay blue. Okay, so once you're happy that you have all of those things I've picked out there, all of those notes in your copy, I want you to watch the video on using litmus paper to test substances and decide whether they're acidic, basic, or neutral. Okay, so remember, if it's acidic, it will turn red. If it's basic, it will turn blue or stay blue, depending on what you use. And if it's neutral, there will be no color change. Okay, so if it starts blue, it will stay blue. It starts red, it will stay red. Okay, so take down the title, equipment, conducting the activity. A diagram would actually be needed as well. So if you could take down a diagram. And then set up your table. Okay, so they have vinegar water here. Like I said, she tests about 8. So you need to set up your table, and then as you go through, write down the substance and decide if it's acidic, basic, or neutral based on the test that she performed. So the best way to do it would be let her dip the paper in, pause it, make your decision. She'll obviously confirm then whether you're right or wrong, and so on and so forth. Is that okay? So that is what I want you to do for today. And like I said, we will perform the experiments ourselves whenever I get back into school. Okay? All right. Oh, when you have this experiment written up, will you take a picture and put it up at Schoology? I'll put up an assignment. Okay? Thanks.